v-SVM. There's another equivalent formulation of the soft margin hyperplane that uses a parameter v, which is chosen between the closed interval between 0 and 1 instead of c, that constant. It was proposed by Sean Kopov et al. In 2000. The objective function is the minimization of 1/2 times the square of the norm of w minus v times rho plus 1 divided by n times the sigma of c to the t summing for all t, subject to the following functions that are to the t times w transpose times x to the t plus w0, which is greater than or equals to rho minus c to the t. This is such a constraint where c to the t should be greater or equals to 0 and rho should be greater or equals to 0 also. And rho is a new parameter that is a variable of the optimization problem and scales the margin. The margin is now 2 times rho divided by the norm of w. V has been shown to be a lower bound on the fraction of support vectors and an upper bound on the fraction of instances having margin errors. That is a sigma of the number of c to the t greater than 0 summing for all t. The dual is that LD equals to minus 1/2 times doubling summation summing for all t and OS of the term alpha to the t times alpha to the s times r to the t times r to the s times x to the t to the transpose times x to the s, subject to sigma of alpha to the t times r to the t summing for all t equals to 0, and alpha to the t is between 0 and also 1 divided by n, and also the constraint including the summations of alpha to the t summing for all t, which is less than or equals to v. When we compare equation 13.19 with equation 13.15, we see that the term sigma of alpha to the t summing for all t no longer appears in the objective function, but is now a constraint. By playing with v, we can control the fraction of support vectors, and this is advocated to be more intuitive than playing with constant c.